Hello everyone. Happy morning to everybody. This is R.AMUTHAVALLI, a Maths teacher. Welcome to Ammu Simple Maths. Dear students, in the previous class I taught you up to question number 10 from your NCERT exercise 12.3 from chapter 12 areas related to circles. Now I can start with the question number 11. Now let me read the question. Watch carefully. On a square handkerchief, 9 circular designs, each of the radius 7 centimeter are made. See the figure. See, this is a square kerchief and 9 circular designs are made, each with the radius of 7 centimeter. Find the area of the remaining portion of the handkerchief. Okay. It's a very simple question. Now, everybody watch this figure given. This is a square kerchief, but the side is not mentioned. Instead of that, it is mentioned that 9 circular designs are made on the square kerchief, each with a radius 7 centimeter. So this is a hint. From this only, you can find out the side of the square kerchief. Why you need the side of the square kerchief? Then only if you know the area of the square, you can very well subtract the area of the 9 circular designs and you can find out the area of the remaining portion. So first you must find out what is the side of the square kerchief. Okay. Now let us analyze the figure given. See, the radius is 7 centimeter. The radius is 7 centimeter. That means the diameter will be 7 into 2. 2 times of the radius. So that is 14 centimeter. So there are 3, see, square. So it has 3, 9 circular designs are made. So 14 diameter. So 3 diameters can fit into the kerchief. That is 14. How much is 14 threes are 42 centimeter will be the side of the square handkerchief. So now side is known. So we can subtract the area of the 9 circular designs from the area of the square kerchief and you can find out the area of the remaining portion. Okay, now let us begin with the solution. The area of the remaining portion of the square handkerchief, that is area of the square, that is ABCD minus area of 9 circular designs. Okay. Now let us list down what is the radius of the circular design. So radius equal to 7 centimeter and A, that is side of the square, is 14 into 3, that is equal to 42 centimeter. So let us write that is A squared minus 9 pi r squared square unit. What is A squared? A squared is 42 squared and 9 pi r squared, 9 into 22 by 7 into 7 into 7. 7 get cancelled. So 9 7s are 63 into 22. 42 square is 1764. If you don't know, you can multiply like this and you can find out the product. So 1764 minus 63 into 22 square centimeter. So 1764 minus 22 threes are 66, 6 carry, 6 22s are 132, 132 plus 6, 138 square centimeter. Now we can subtract 1386, 1386 from 1764. So 8, 15, 7, 6 minus 3, 3. So the answer is 378 centimeter squared. So if you subtract the area of the 9 circular designs from the area of the square kerchief, you got the answer as 378 centimeters squared. It's a very simple question. By seeing the figure, you have to find out the side of the square. So because the hint given is the radius of the one circular design. So from that you can find the diameter and you have to multiply by 3. So thereby you can find out the side of the square kerchief. Next, let me work out question number 12. In the figure, OACB is a quadrant of a circle with the center O and radius 3.5 centimeter. If OD equal to 2 centimeter, find the area of two parts are there, two subdivisions are there for question. First part is you have to find the area of the quadrant OACB and the shaded region. See here I have shaded with blue color. So these are the two subdivisions of the questions. Okay. Now let us poster the values. What are the data given in the question in the figure? So it will be easy for us to step into the solution part. It's a quadrant it is given. So yes, and the radius is 3.5 centimeter. So this OB is 3.5 centimeter. OA equal to OB equal to radius 3.5 centimeter. And OD is given as 2 centimeter. Okay. Now, quadrant OACB is a direct question. You all know what is the area of the quadrant. That is theta by 360 pi r square, 90 degree you can put, or otherwise pi r square divided by 4, because a quadrant means 1/4 part of the circle. So 1 by 4 pi r square, that will be the formula. And here shaded region, how can you find this area of the shaded region? From the area of the quadrant, you have to subtract the area of this triangle. What type of triangle it is? In a quadrant, the central angle is, you all know, 90 degree. So this is a right triangle. So for the right triangle, you can make use of the formula of BH. So this radius OB is acting as a base, and this OD is given the measurement, that is the altitude or height, that is 2 centimeter. So by you making use of these two measurements, you can very well find out the area of the triangle. You can subtract the area of the triangle from the quadrant and you can find out the area of the shaded region. Okay. Now let us write first part. Area of the quadrant equal to pi r squared by 4 square units. This is a formula. Now let us substitute the value. R equal to 3.5 centimeter. 22 by 7 pi, and R is 3.5 into 3.5 by 4. Okay. Now 7 and 3.5, that is 1 time 0.5. Okay. Next 22 into 5, 110. So 11.0 into 3.5 by 4. So here the numerator decimal numbers are there. So carefully you multiply. 5 11s are 55. 5 carry. 3 11s are 33. 33 plus 5, 38. So that will be 1 decimal place. Here 1 decimal place. So 1 decimal in the product. Divided by 4. See, in the numerator decimal number should not be there. So you can divide by 4. Yes, 4 9s are 36. If you want, you can do. I will do and show you. Yes, 4 9s are 36. So 0.25. How many times? 6 times are 24. 1 0. 4 2s are 8. 2 0. 5 4s are 20. Here see, this is in the form of P by Q. Q's prime factorization is, that is 4 is 2 squared. Please try to recall what you studied in the first chapter, real numbers. If the prime factorization of Q is of the form 2 to the power m or 5 to the power n, then the decimal will be terminating decimal. So like that we have obtained terminating decimals. 9.625 centimeter square. Centimeter square. So this will be the first part answer. Next, second subdivision, let us move. Area of the shaded region equal to area of the quadrant minus area of triangle BOD. BOD. It is square units. Area of the quadrant is 9.625. This is from 1. Minus area of triangle BOD is half into B is OB into OD square centimeter. So let us substitute the values. Yes. Half into OB is 3.5 and OD is 2. So 2 get cancelled. So 9.625 minus 3.5. Here 3 decimals. So we can make it as equivalent decimal. That is centimeter squared. So the answer will be 5216. 6.125 centimeter squared. This is the answer. So the first part, it's a direct question. The second part, area of the shaded region. From the first part, what answer we obtained, that is the area of the quadrant. We subtracted the area of the triangle. Since it's the right triangle, so we substitute the values for the base 3.5 and for the height 2 centimeter. And 3.5 is the area of the triangle. We subtracted from 9.625 and we got the answer as 6.125 square centimeter. Children, now let us move on to the next question. Question number 13. In the figure, a square OABC is inscribed in a quadrant OPBQ. If OA is 20 centimeter, find the area of the shaded region. Use pi equal to 3.14. See, by seeing the figure itself, we can understand how to find the area of the shaded region. Because it's a simple question. Because here OABC is mentioned. OABC is mentioned as an inscribed square. That is, inscribed square means that is within inside the quadrant a square is formed. So OPBQ is a quadrant and this OABC is a square. For that the side is given. The side is 20 centimeter. So that means the square, it has all the sides equal 20 centimeter. Now how to find the area of the shaded region? From the quadrant's area, we have to subtract the area of the square. Okay, that is clear. For finding the area of the square, side is known. So a square easily you can find out. If you want to find out the area of the quadrant, then you must make use of the formula theta by 360 degree into pi r squared, where theta is 90 degree, or we can make use of the formula pi r squared by 4, because you all know quadrant means 1/4 of the circle. So pi r squared is the area of the circle divided by 4, 1/4 of the area of the circle. That will be the area of the quadrant. So for that, you must know what is radius, how much is radius. The measurement is not given. So the only data given is the side of the square. So you have to find out the radius of the quadrant. So what is radius of the quadrant here? That is OP, OQ, OB, that all these are radius only, because this is the curve actually. So OB is a radius of the quadrant. Now this radius OB is nothing but the diagonal of the square. Already in your lower classes you have studied what is the diagonal of a square. If A is the side of the square, then its diagonal will be root 2a units. This is the formula. So you can recall the formula and you can make use here and you can find out the radius of the quadrant. Otherwise, you can make use of Pythagoras theorem, because see, everywhere it is all the four sides 90 degrees formed. OA and AB are perpendicular to each other. So OAB is a right triangle. So OB is the hypotenuse. So OB can be found out from square root of OA squared plus AB squared So that is equal to 20 squared plus 20 squared. So 2 into 20 squared. 20 squared if you take out of the square root, that is 20. 20 into root 2. So 20 root 2 centimeter. Or directly, if you can recall the formula, so root 2 into A is 20 centimeter. So 20 root 2 centimeter. So like this, by making use of the previous knowledge, you can easily find out the diagonal of the square. The diagonal of the square is nothing but the radius of the quadrant. Now radius also now known. So now the way is clear. Now readily we can substitute the values in the formula and we can find out the area of the shaded region. So shall we commence with the solution? The area of the shaded region is equal to area of the quadrant. Let us write the name of the quadrant, O, P, B, Q, minus area of the square. Let us write down the name of the square, O, A, B, C, square units. Let us write the formula, pi r squared by 4 minus area of the square is A square, square units. Let us list down the values. R is 20 root 2 centimeter and A equal to 20 centimeter. Now we can substitute. Pi we have to make use 3.14. So 3.14 into 20 root 2 by 4 minus here A squared is 20 squared square centimeter. Okay. Now 4 ones are 4 and 20. See, 4 is a common factor for 20, so we can cancel. 4 ones are 4 5s are, and 5 into 20 100. Root 2 into root 2 is 2. So that is 3.14 into 100 into 2. 20 square is how much? 400 centimeter square. 3.14 into 100 is 314 into 2, that is 628 minus 400 centimeter squared. 628 minus 400 is how much? 228 centimeter square. So by subtracting the area of the square from the area of the quadrant, we obtain the answer of the area of the shaded region as 228 centimeter square. Yes children, now let me work out the next question. Question number 14. AB and CD are respectively arcs of two concentric circles of radii 21 centimeter and 7 centimeter and center O. See the figure. If angle AOB equal to 30 degree, find the area of the shaded region. Okay. Now observe the figure. AB is the one arc and CD is another arc. This shape itself reveals this is the sector. So it is the two sectors cut from the two concentric circles. Concentric circles means you all know with the two circles. These two circles are keeping the same center O. It has been drawn. From that, two sectors are cut off. That is the big sector. So AB is the arc of the big sector and CD is the arc of the smaller sector. So they are having the same center O, and it is also given the angle AOB is 30 degree. That means for both the sectors the central angle is 30 degree. Now how can you find the area of the shaded region? It's quite obvious. Area of the bigger sector minus area of the smaller sector. So the area of the bigger sector is that is OAB. OAB is the bigger sector and OCD is the smaller sector. And if you subtract OCD, area of the smaller sector, from the area of the bigger sector, you can find the area of the shaded region. Okay, now let us begin with the solution. Area of the shaded region is area of bigger sector, that is OAB minus area of smaller sector OCG square units. Okay, for the bigger sector, the radius is given as 21 centimeter. So, in order to differentiate, let us note down as capital R equal to 21 centimeter. And for the smaller sector, let us take the radius as small r, and it is also given, that is 7 centimeter. So, we can make use of these values in the formula. What is the area of the sector formula? Theta by 360 degree pi capital R squared minus theta by 360 degree pi small r squared square units. So let us simplify the formula. Here theta by 360 degree, this is a concentric circle, sectors taken from the concentric circle. So same this thing, central angle, it is given theta is 30 degree. So shall we take theta by 360 degree and pi outside? So theta by 360 degree pi, and within bracket r squared minus small r squared square units. So 30 degree, theta is 30 degree by 360 degree, and pi is 22 by 7, r squared is 21 square minus 7 squared square centimeter. 30 ones are 30 12s are. And here 12 and 22, 2 is a common factor, 2 6 are, 2 11s are. Okay. Now this 21 square into 7 square we can write, that is r squared minus r squared, we can write by making use of the algebraic identity, r plus r into r minus r, that is 21 plus 7, 21 minus 7. So that implies 11 into 6 into 7, that is 28. 21 plus 7 is 28. 21 minus 7 is 14 square centimeter. 7 ones are 7, 2s are 2 ones are 2 3s are. So in the numerator 28 into 11, 8 11s are 88, 8 carry, 2 11s are 22 plus 8, 30, 308 by 3 centimeter square. So the area of the shaded region is 308 by 3 centimeter squared. I hope the solution is clear, since it's a very simple figure. So all these details are given. Just we are substituting in the formula and we have obtained the answer at the area of the shaded region, that is 308 by 3 centimeter squared. Children, if you have any doubts in these questions, you can ask in the comment section. Thanks for watching. I wish you all a very happy learning.